Okay, so we're going to go over 3.8, which is the very next section. And so it starts off as graphing these functions. And if you remember when you're graphing these functions, because it's in this really nice, like, it shows you all the shifts, you can actually see it. So my brain says, oh, it moved left 2, it flipped upside down, and we moved up 1. Okay, so those are the shifts, and you can kind of see that it looks like this, right? Right, it looks like this. Same thing goes with this. The half, does everybody remember what the half does to your function? The half makes it fatter, that's all. All right, so here's what we're going to do. We're going to break down a polynomial function to find the roots, and we're going to write a polynomial function in factored form. So we're, instead of going from roots to factors, we're going from like standard form of a polynomial that looks like this to his factored form. Okay, that's our goal for today. So it says previously we learned to predict the number of roots of a polynomial function using the fundamental theorem of algebra and the relationship between the roots and factors. In this lesson, we will be working on how to find all of the roots of the polynomial given in standard form. So first of all, if you know, so this is the key part for the whole lesson. If you know that 7 is a factor of 147, would you be able to find the rest of his factors? If you knew that 7 was a factor of 147, would you be able to find the rest of his factors? And the answer is yes, right? So the very first thing that I'm going to do is I'm going to divide. I'm going to divide 147 by 7. And you guys are like, oh, Ms. Johnson, that's just 21. Okay. So then when I'm factoring it, oh, and then I could just factor this 21 to find the rest of its prime factors. And you're like, yeah. Okay, so then I go 21 and I'm like, oh, that's just 3 times 7. So the prime factorization of 147 is going to be 7 times 7 times 3. So that's basically what we're doing. We're going to take 147, a polynomial, and we're going to write it in factored form. Factored form looks like parentheses, parentheses, parentheses. Does that make sense? So how is your polynomial here like this? 7, 7, and 3. Do you guys all see the analogous of that? Okay, the process for finding factors of a polynomial is exactly like the process for finding factors of numbers. We start by dividing by a factor we know, and then we keep dividing until we find all the factors. When we break down a polynomial into a quadratic, sometimes we can factor it by inspection, and sometimes we have to use other tools such as the quadratic formula. So let's try. So the very first thing that I'm going to do, and this is probably the only example I'm going to do in this video, is we're going to start with this. So this is our 147, and then this is our 7. And I say, I'm telling you that this is a factor of this thing. So now what should I do? So you say, oh, Ms. Johnson, you divided. Should we start by dividing? Exactly. So I'm going to start by dividing this guy. So here goes x cubed. I need to move this. Plus 3x squared minus 4x minus 12. Okay, and we're going to divide it by 3. X plus 3, sorry. I was thinking of this other way that we could do it, but I'm not going to show you. So I'm going to go through this division really quickly, relatively quickly, because you guys all know how to do this. So I say, how many x's go into x cubed? And you all say, oh, it's x squared, Ms. Johnson. And then I'm going to multiply, and I go x cubed, and I get 3x squared. And then I'm going to subtract, and then I'm going to change my signs. And look at that. Everybody goes away. Boom, boom. Right? And so I'm left with negative 4x minus 12. And I say, how many x's go into negative 4x? And I'm like, oh, that's negative 4. Oh, and some of you like to put stuff on top of stuff. So let me put it on top of where I think you would put it. And then, so then I distribute, and I get negative 4x, and I get minus 12, and I'm going to subtract. So that means I'm going to change my signs, sorry. And then, so that's a 0. Shouldn't it be a 0 though? Am I surprised that this is a 0? Am I surprised that this is a 0? No. How do I know that this should have been a 0? Yeah, because of these words here. They said, hey, this is a factor. Because this is a factor, that means this has to be a 0. Right? Because it's a factor, the remainder has to be 0. That wasn't a surprise for me. Okay. All right. So then what happens? Okay. So now so far I have it written like this. I have x plus 3. And then I have this x squared minus 4. And then I have this x squared minus 4. I'm going to try to factor this guy into its smallest parts, meaning all of my factors are all of the, like the highest power is x. So I'm looking for how to factor this. Does anybody remember how to factor x squared minus 4? Does anybody remember how to factor x squared minus 4? There's a shortcut. I'm just curious if anybody remembers. So if you do remember, it's called the difference of squares. It's x plus and x minus. The reason why I know this is a difference of squares is because number one, there's a minus staring at you. And this is a square. Is 4 a square? Is 4 a perfect square? Yeah, you got it. Someone said it in the chat. Awesome. Very good. Yeah, it's a perfect square. What squared gives me 4? Very good. It's 2. So then this guy would be x plus 2, x minus 2. So I would write it as x plus 2, x minus 2. All right. Couple different ways that you could check it. Number one, use Desmos. Number two, just do this like quick check. This is my quick check. X times x times x. I'm going to do all the firsts. That's x cubed. Is 3 times 2, which is 6, times negative 2. Is it really negative 12? And you're like, yes. Very good. So here's my factored form. Right? And then if these are my factored forms, are you able to get to your roots? And you guys are like, yeah, that's easy, Miss Johnson. Yes. If you understand the relationship between these two, you will get it. Yeah. So what are my roots? Very good. Someone said negative 3, 2, and negative 2. Very good. Very good. Very good. The order which you write these, the order which you write the factors, it doesn't matter, right? Because 2 times 5 times 3 is the same as 3 times 5 times 2. You can put these in whatever order you want. So this is how you find all the factors. Given a factor, you divide it out. No surprise that my remainder was 0. And then you keep factoring until you're done. This is how I factor. I say, hey, are you completely factored? And I'm like, yeah, there's nothing else I can take out of an x plus 3. And I say, hey, you, x plus 2. Is there any way that I can factor anymore? And you're like, no. What about you, x minus 2? So I'm going to go up to every single factor and see if I could break it down any more. Okay. So it said up here, break down a polynomial, which we did, and we can write a polynomial function in factored form. So here's an example, and then we will continue this later. Thanks for listening.